Okay, so part 2 of my PBA, my final project. So I'm going to start with quarter 2. So for quarter 2, what I liked was the parent function translation with all of the different types of functions like square root, quadratic, cubic. I just like translating because I find it really simple, and I don't know, I just think it's just really simple. So let's just give an example. So let's say we want to go right 4 down 3. Okay, so if I were to do a quadratic, then it would kind of look like f of x equals x minus 4 squared minus 3. And let's just say rational. And it would look like f of x equals 1 over x minus 4 minus 3. Okay, so all of the functions kind of follow the same pattern, so it's really simple to pick up. So the negative 4 is derived from the right 4, because it'll always be, if you're going left or right, then it's always going to be opposite, because, yeah. And then down and up is basically the same. And let's say if I were to just put a negative right here in front of here, then it would reflect over the x-axis. So, and if I were to put a 3, then it would dilate. So just wherever you put it, it's just kind of, it's really simple, I think. So that's why I liked it. The thing that I didn't like was definitely the complex number system. It was definitely difficult for me to pick up. Okay, it's kind of hard to pick up because it's kind of like learning a whole new number system almost. It's really confusing. Okay, so the best way that I can explain it is through a square root. So if you were to have a negative 12, square of negative 12, which technically is impossible considering that that technically, like, you can't have a negative and a negative, because if you have a negative times a negative, then it would equal a positive. If you have a positive times a positive, then it would equal a positive, which a square root is basically 12, like 6 times 6, or 7 times 7, or 2 times 2. Kind of get what I'm saying. So let's say if we were to do, let's see, square root of negative 16. So we know that the square root of 16 is 4, but because it's technically imaginary, then you have to add the I. So it's just, you kind of add an I if it's a negative or irrational, like pi or something like that. It's really confusing, and really hard to explain. But once you get the hang of it, it gets easier. So moving on to quarter 3, the thing that I liked was nth roots, and I actually did nth roots for my last project, which was really easy, so yeah. Okay, so for nth roots, you can just go over some of the parts. There's going to be an index, and if there is no index, then it's always assumed to be 2. and there's going to be a radican, and the radical sign. So, okay, so we can try a couple of problems. So, let's try a really easy one, x squared y 4, and so since there's no index, it's assumed to be 2. So, people can only travel in pairs of 2, so I can bring one pair. 2 pairs are coming from y, so it'd be x, y squared, because one pair came from x and 2 pairs came from y. Now let's say that we have something left over, like index is 3, 8, A 6, B 5, C 7. So this can break down into 4, 2, 2, 2. And so this can travel in, so this brings over to 2a squared, b c squared, and make sure whenever you're doing the question, make sure you always add the index. And then you are left over with a b squared c. Okay, so now we can kind of look over it. So you get the 2 because there are 3 of the 2s, so that's 3 of a pair. And then out of A6 you can get 2 groups. Out of B5 you can get 1 group, but there's still 2 left over, hence why it's B2 right there. And then C is kind of the same case. You have 7, and you can get 2 out of, and then you're left with 1. So yeah, so it's kind of simple. Yeah. So the thing that I didn't like was solving radical equations, which can be hard, but it can also be easy. So it just depends on what your strengths are and what you aren't. But I thought this was okay. So let's do an example. So if I were given radical x plus 31 equals x plus 1. First of all, you want to get rid of the radical sign, so you would square it. So you would end up with x plus 31 equals x squared plus 2x plus 1. And so then from there, you would add, or subtract actually in this case, 31, and that would get you to x squared plus x minus 30. And so then you would find the factors of that, x plus 6 and x minus 5. And then if you're solving for it, then x would be the opposite of these, because that would be the roots, -6 or 5. And that's pretty much it. All of them are that way, you just solve. So yeah. So moving on to quarter 4, the things that I like the most were definitely circles. So, okay, let's see. So let's say that